Hello everybody, I'm Gianluca Panarelli and today we're going to solve together a physics exercise from my school book about the RL circuit. So, I've chosen to do the number 61 of page 44. The book is an American book of the Pearson, is the third volume of physics written by James Walker. Now let's read together the instructions of the exercise. The circuit showed in the picture is formed of a battery of 6 volts, an inductance of 37 mH and 4 resistances of 55 ohm. 1. Calculate the time constant of the circuit. 2. What's the current of the circuit at the time of two time constants after the closing of the circuit breaker? 3. What's the current of the circuit after lots of time from the closing of the circuit breaker? First of all, I drew the circuit on my notebook. Then I started from the first point. The time constant of an RL circuit is defined as the inductance divided by the resistance, that in this case has to be calculated as the total resistance. In fact, as you can see, there are 4 resistances, so we need to obtain the final one. So, from the drawing of the circuit, you can see that the resistance 1 and resistance 2 are in series, so they can just be added and the circuit became as in the video. Then the resistance 3 is in parallel with the resistance 1 plus 2, so they can be added, but we need to make them at the minus 1. Now the circuit can be simplified as in the video. Finally, the resistance 1 plus 2 plus 3 and the resistance 4 are in series, so I can just add them. The final value of the resistance is about 55.02727 that we write as just 55. Now we can calculate the value of the time constant, which is 6.72 for 10 to power of minus 4, which we can write as 7 for 10 to power of minus 4. The first question is solved. Then the second request is the value of the circuit current at the time of two time constants after the closing of the circuit breaker. Here we need to apply the formula of the RL circuit current using the value of two time constants as time. The value is 94 milliamperes, which we write as 0.1 ampere. Finally, the third point asks the value of the current after a long time. We just use the formula of the second request, but this time we can use plus infinite as time. This mathematically is an undefined form, which we are going to simplify because theoretically this value couldn't be calculated. So, infinite divide for a number is always infinite. There was a minus, so it becomes minus infinite. Nepero's number to the power of minus infinite tends to 0, so we write 0. 1 minus 0 is 1, so the fraction remains the same, and the value is about 100 milliamperes, which which we can simplify as 0.1 ampere. Also, the last third point is done. So all the points of the exercise are solved. The values are not the same of the book, as you can see, but I think that simplifying changes a little bit the final values of everything. I may made some mistakes, but it was an exercise, and this time I solved it using this process. If you want to suggest me other processes, write them in the comments. I hope you enjoyed this video and see you next time. Bye!